In this video, we're going to explain the Solver tool in Excel. So the Solver tool, you can think about it as the goal-seek tool on steroids because it's a much more powerful version of the goal-seek feature. We've explained the goal-seek feature in Excel on a previous video, and if you haven't watched that video and you don't know about the goal-seek feature, I'd recommend you watch that video first, and I'll leave you the link for the video down below in the description. So here we have the same example that we solved using the goal-seek feature. And actually the main difference between the goal-seek feature and the solver feature is that the goal-seek feature can deal with only one variable, while the solver feature can solve a problem with multiple variables. So we're going to start with a simple example and solve the same problem that we solved using the goal-seek feature, but this time we're going to use the solver feature. And the problem was that we need to know the break-even point for this factory producing a product with some fixed costs, and we have here the variable cost per unit and the selling price per unit. So we need to know the break-even point, which is the number of units that we need to sell in order to make our profit zero. And the profit, of course, depends on the revenue, which depends on the units sold. So the profit depends on the units sold. So to use the solver feature, we can go to the data tab on the ribbon, and here under the analyze group, we can find the solver tool here. But if you don't have the solver tool under the analyze group, then it might not be activated on your Excel. So to activate it, you can right click anywhere on the ribbon and then customize the ribbon here, and then click on add-ins, and then you need to make sure Excel add-ins is selected and click on go, and then make sure to check the checkbox for the solver add-in and click OK. So now we can use the solver feature. We can go to data and then solver, and then here the first input is that you need to set your objective. Your objective is basically what you need to achieve. And what we need to achieve is that this cell here, which is cell B20, to be equal to the value of 0, because we need the profit to be 0, and we need to find the number of units sold in order to make the profit 0, which is our break-even point. And you can also change some variable cells, and the variable cell that we need to change is the units sold. This is what we need to change in order to make the profit 0, which is going to make us reach our break-even point. And then we can also add some constraints. So we can add a constraint, for example, that the units sold would be an integer, because we cannot produce like half a unit. We should be only producing one whole unit of our product. So if we click on add, we can add constraints, and we can tell Excel that we need this cell to be an integer. We can select int here and then click on add, and if we click OK, it's actually going to tell us that the server reference is empty or contents are not valid, because it expects that there is something here inputted, but we've just added it, so we can just cancel, and we'll see here that our constraint has been added. However, doing this and adding this integer constraint is actually going to make us not find a solution. And this is because an integer value for the units sold is not going to make the profit exactly 0. So this is why it's not going to be able to find a solution. If you click on solve here, you'll see here that solver cannot find a feasible solution, because an integer units sold is not going to get us the solution. And actually on the previous video, we got a solution that was a fraction for the units sold. So we would just round to the nearest higher integer. If we click again on solver here, if we remove this constraint and click on solve, you will see here that we managed to reach the solution. And the solution is that we need to sell 2,448 units, because we need to round it up to the nearest integer in order to reach our break-even point. So if we click OK here to keep a solution, this is going to be our solution, which is the same solution that we obtained using the goal-seek feature on the video that we created about goal-seek previously. And you'll find the link to the video down below in the description. All right, so we've solved a simple example and the same example that we've shown when using the goal-seek feature. Let's actually show a more advanced example. All right, so let's see a more advanced example. Here we have a factory producing 5 products, and what we have here is the demand that the market needs, which is basically the number of products that the market needs from our factory. We have also the variable cost per unit, and we have the selling price per unit for each product. And what we need to get is the units produced. We need to know the number of units to produce of each product in order to gain the maximum profit. So we have here a profit formula here, which is simply the difference between the selling price per unit and the variable cost per unit multiplied by the number of units produced. And then we would also subtract from that our fixed costs. But we have also a constraint, which is that our production capacity for our factory is only 10,000 units, while actually the total number of units the market needs is 18,026. So you can see here that we are not able to satisfy the demand for the whole market, and we need to make sure that we produce the products that would provide us with the maximum profit. All right, so let's get to work and solve that using the Solver tool in Excel. So we'll go to the data tab on the ribbon and we'll click on Solver here. And first, we're gonna give it our objective. And our objective is to actually maximize the profit here. So this is gonna be our objective. So it's the maximum of our profit. And then we need to give it the cells that we need to change in order to achieve that objective. And actually the cells that we need to change are these cells here for the units produced, because we need to know the number of units to produce of each product in order to achieve the maximum profit. So you can give the Solver tool these cells as a single cell or as a range. And of course you can give it multiple combinations of single cells and ranges, but in this case it's just this one range of cells. So I'll just select that, and then we have some constraints as well that we need the Solver tool to respect when providing us with a solution. So the first constraint that we have here is that the production capacity is equal to 10,000 units. And the production capacity being 10,000 units means that the summation of the units produced needs not to be more than 10,000 units. And here in this cell, which is E9, we have actually a formula that sums the units produced. So we can actually add here that the value in this cell should be less than or equal to the constraint, which is 10,000 units here. So now we can add that as a constraint, and let's add more constraints as well. So one more constraint is that we need the units produced here to be integers, because we cannot produce half a unit. So we need to make sure that the units produced are integers, and let's add that constraint as well. And another constraint that we have is that we need the units produced for each product to be less than or equal to the market demand for that particular product, because we need to make sure that all what we produce is sold on the market and that we don't have any leftovers. So in order to do that, we need to make sure that the units produced for product 1 is less than or equal to the demand for product 1, and let's add that as a constraint, and we'll rinse and repeat for each product. So the units produced for product 2 are less than or equal to the demand for product 2, and then units produced for product 3 are less than the demand for product 3, for product 4 as well, and for product 5. And we're done with all our products. Let's click on cancel here, and you'll see here that all of our constraints have been added. We have also this option here to make unconstrained variables non-negative, so that any unconstrained variables would be just positive numbers, they wouldn't be negative. And let's make sure that this is checked because we don't want any negative numbers here. And now we can select a solving method. So in order not to give you a math class here, because this is definitely not a math class, we have 3 solving methods to choose from when using the Solver tool. So to give you the shortened sweet version, basically GRG nonlinear and evolutionary are used for nonlinear problems. GRG nonlinear is much faster, but at a compromise, which is that it might not find the best solution if there are multiple solutions for our problem. So it will find the nearest solution, but not necessarily the best solution. And evolutionary will take a much longer time, but it can find you the best solution out of multiple solutions that would fit our problem. If your problem is a linear problem, then you can use the simplex LP method. Our problem is a nonlinear problem, so we should be using GRG nonlinear or evolutionary. And most of the problems you'll be solving will be nonlinear problems, so you'll be rarely using the simplex LP method. And in order to compare between GRG nonlinear and evolutionary, for this problem on my computer, if you use the default options for GRG nonlinear, it would solve the problem in 1 second, while evolutionary can take about a minute to solve the problem. However, you can actually do a compromise. If you click on options and click on GRG nonlinear, you can do a compromise here, which is to use multi-start, as this increases the chances of GRG nonlinear to find the global optimum, i.e. the best solution. However, this increases the time for finding the solution, but still, it would usually take less time than the evolutionary method. So this is what we're going to do here. We're going to click OK, but most of the time, GRG nonlinear with the default settings should do the trick. And you can always experiment with the different methods. So if you click on solve here, you will see here that it will take some time because we're using GRG nonlinear with multi-start. So it will take less time than the evolutionary method, but more time than GRG nonlinear without a multi-start. And you can see here that solver has converged to the current solution. All constraints are satisfied. Let's click OK. And as you can see here, we get our solution, which is that our maximum profit is going to be $80,077.09, with the units produced from product 1 being the maximum for the demand here, which is 3,891, while from product 2 we produced 2,472 units, and for product 4 we produced 3,637, and we wouldn't produce anything from product 3 or product 5. So this is actually the solution to give us the maximum profit. If we try solving that problem again with GRG nonlinear without multi-start, so if you go here and disable multi-start here, and then click on solve, you'll see here that it takes just a second to solve the problem. You can see here that is much faster when not using multi-start. So as you can see here, the solver tool in Excel is quite powerful for solving optimization problems with multiple variables. And before I go, I would like to ask you a couple of questions. Do you think the solver tool is going to be useful at your daily job? And what problems are you going to solve with it? Let me know in the comments below. So that's it, guys, for today's video. If you've watched the video till this point, thank you so much for watching, and please make sure to like the video and share it with your friends and subscribe to the channel and hit the bell icon to be notified of future videos. And you can also follow us on different social media platforms. You will find the links down below in the description. Thank you so much for watching, and I'll see you on the next video.